Hi, Assalamualaikum, and a very good morning. My name is Aman Muhammad Ihsan. Today I will present the um, for the Iidex 2025. So my innovation is on the interactive turbomachinery design dashboard. My name is Aman Muhammad Ihsan bin Muhammad. Little bit about myself. My full name is Associate Professor Dr. Aman Muhammad Ihsan bin Muhammad. Currently, I'm director for the Smart Manufacturing Research Institute, and then I now presenting for the Faculty of Mechanical Engineering, which is my forte. So my specialization is on the turbo machinery and energy recovery. So a brief about the innovation description. So this dashboard was developed by using the Excel software. So whereby the turbo machinery designers, such as the student and as well engineers, can adjust their input like the flow angles, the mass flow rate, velocity, RPM, revolution per second, turbine speed, compressor speed, and then as well with the required the pressure ratio for the compressor. And this will automatically calculate the sizing, and the users can instantly see the impact of the performance of the requirements, and as well with the velocity triangle into the graphical visualizations in two-dimensional, and this is also can be exported into the three-dimensional streamlining that can be integrated with the um, Katia 3D and as well with the CFD analysis. So the key innovation is from this innovation that I had designed, which is actually is a one platform that using the Excel, very simple, very common, combines with the analytical modeling, visualization, and able to be exported in three-dimensional points, which is derived from the design. So it also dynamic where the users can instantly interact with the user requirement, and they can see, they can visualize the impact of the changes of the requirement, and as well the changes of the velocity triangle that been input into the independent variables for the calculations. Then it also can be used as educational and as well with the designed utilities, so that it will collate all the complex parameters for the student, for the designer, for the engineers to look upon. So it's required for the bridging between the theoretical and three-dimensional turbo machinery design, which is a very difficult for the engineers, for the for the students, for the senior student to understand, and as well to appreciate how that this turbo machinery can be done. So the approach that we use here is to use with the Excel dashboard, and it can be visualized and export into the computer aided design. So in terms of the benefit, it is a fast, free, it can become as the open source software for the student and engineer, and it is very friendly. So in terms of competition with the current expensive design software for the turbo machinery, so this is cost friendly. So this is it can be at a zero cost. So it's utilized from the Euler and all Euler equations that been used with the um, fundamental equation from the thermodynamics, from the fluid mechanics, and can be ready for further deep analysis. So next, we will continue for how that this turbomachinery design dashboard. So this is the interactive turbomachinery design dashboard that had been designed. The As you can see from the screen, there are two sections of the dashboard. On the top section is the dashboard for the compressor, and on the lower section is the dashboard for the turbine. So on the left side give you the requirement of the turbomachinery design, whether it is for the compressor or the turbine. The user can give an input into the compressor, or the user also can roll up or down the input, such as the mass flow rate, the RPM, and the pressure ratio required. So from this button up and down, it will increase or decrease as according to the user requirement. So as you can see here, it will be automatically calculated and give you, as you can see, if we change the mass flow rate, then you can see the compressor isentropic power will be automatically changed. Do as well if you scroll up or down the RPM. So the revolutions per minute of the compressor, and as well for the turbine. So if you see here, if we change the RPM, then it will change the RPM for the compressor and for the turbine, and as well for the pressure ratio. So the pressure ratio, which is at the inlet and outlet of the compressor. Okay, so if you change this one, you get more sensitive of the calculation, whereby here you can see the requirement of the turbine also will be changed. So this is a relative. Okay, so then if you're going to increase the RPM of the compressor, then or decrease this one. Okay, so 120,000 for example for the design point. Let's take that one, and then we decrease that or increase of the RPM. Then here the say that this is going to be the output sizing of the compressor and the turbine. So here is the basic layout for the compressor, that it will give you the basic sizings, and it will be automatically displayed into this right side. So here, since the turbine and compressor involved with the three-dimensional velocity component, so it will involve with the absolute relative velocity and meridional velocity of the inlet and the outlet. So thus as well, the absolute and relative angle will also varies as according to the requirement and the selections. So if we select, for example, WQ2 is actually the relative exit velocity, A2 the absolute velocity, R1S, R2 is the ratio of the inlet and the outlet of the compressor radius, and V is the inlet compressor radius ratio between the hub and shroud. So the hub is the lowest part curvature, which is given by this one, and the shroud is the highest part of the compressor impeller. Then on this left side of the layout shows you the velocity triangle. So when we do the selection of the relative velocity or angle, the velocity triangle at the inlet and as well at the outlet will be changed automatically. So the users, which is the student or the engineer or the turbomachinery designer, can directly and immediately see the situation, the conditions of the velocity triangle, which is very important for them to understand and as well to realize what will be happen. So it also give the Mach number um, of the relative velocity, of the absolute velocity, of velocity triangle on this velocity triangle display. And as well, if you change this condition for example the radius ratio, and it will give you automatically the layout sizing, and this is will change automatically. So the designer will at least can visualize what will be the output in terms of two-dimensional output for their compressor, okay, and the effect of the velocity triangle. So this side is the Meridonian view. This is the camber line view, which showing the outline of the compressor, and this is the frontal view of the compressor. Whereas on the downside, you can see the setting view for the turbine. Similarly, we can adjust the absolute angle, the relative velocity, the ratio of the inlet and outlet radius, and as well the inlet hub and shroud ratio. So if we change here, for example, that you can see the sensitivity, and as well here you can see the the values also will be displayed in this location. So all of this will be automatically displayed and can be visualized by the student and as well by the engineer who are using this interactive dashboard. So finally on this side, which is the integration of how the compressor and the turbine will be looks like, whether it is the sizing of the compressor and turbine will be suitable or not. So as you can see here, when we change this one, it also will be varies. So this is the meeting point between the compressor and the turbine. So this is all for my presentation for this interactive dashboard. So in terms of the status potential, this technology readiness level is in the stage 4, whereby we need to confirm, we need to validate with the prototype. It can be applicable for the design and education. As a market potential, this is open source software, and we have obtained the copyright from the MyAPO, which is the number is CRLY 2025W08295. In terms of the quintuple helix that we had obtained, so in terms of academia, it's a transformative educational and research tool. Industry, we can accelerate the R&D cycles and lower the barrier for the design entry. In terms of the community, the community can understand, democratize the usefulness of energy to be fully optimum. So in terms of the environment, enables the design to be more efficient for the turbomachinery energy utilization, that we can capture more energy, we can convert more energy to be more energy utilizations. And finally, is a practical tools to achieve national and international sustainability for the toward the clean energy, whereby that we have the new energy transformation roadmap for the current, whereby we can further utilize the energy and convert this into the useful power source. So that's all. Thank you very much for your time.